Okay, a couple more problems dealing with the Pythagorean theorem, technically dealing with the Pythagorean theorem. And if you have a square, the distance from A to C is equal to 10. So if that's equal to 10, we want to find the distance from A to B, but because it's squared, all the sides are the same. So technically you could use the Pythagorean theorem. X squared plus x squared equals 10 squared. So you could have 2x squared equals 100. So you divide each side by 2 and x squared is equal to 50. So x equals the square root of 50. For the exam, an approximation for the square root of 50 is fine. You should be able to write that as square root of 25 times square root of 2, which means the simplified form is 5 times square root of 2. Now you could also get that answer by using the 45-45-9 triangle theorem, which we'll go over on a later sample problem. The other type problem I want to review right now is when you have an isosceles triangle, two sides are equal. So we're going to take this triangle, draw in the altitude that passes through point A, and that's supposed to be perpendicular. So if the distance set from B to C is equal to 8, then each of these individual segments has to be equal to 4 because we've divided the isosceles triangle into two congruent right triangles. So therefore, if each of these sides is equal to 20, we can solve for x by looking at either of the right triangles and saying 4 squared plus x squared equals 20 squared. So 16 plus x squared is equal to 400. We can subtract 16 from each side of the equation, and we have x squared is equal to 384, and x equals the square root of 384, which you could write in simplified radical form, or you could just, for the exam, put that into your calculator and get an approximation. So we'll leave that in that form.